aspects, we discuss about the force and the force that is causing the motion. So we'll be dealing with both the kinematic aspects of it, the motion that has been causing, and what is the nature of force that is causing. Generally, whenever we define force, force is defined from Newton's second law of motion. Generally, there are three laws, Newton's. So if you write Newton's laws, well, Newton's laws, you know it, the first law. If you look at first law states that a body will be in state of rest or in state of motion unless and until some external force acts on it to change its state from rest to motion or motion to rest. This is your concept of inertia. So first law talks about concept of inertia. So suppose there's a very big boulder, maybe around 100 kg in weight, and I'm applying some force, some external force. This applied external force should always be more than the inertial force or equal to. Then impending motion starts. If the external force that is applied is less than the inertial force, then body does not move. It is still under static condition. This is under static condition. So Newton's first law states that whenever a body is in state of rest and you apply some external force, the body will change its state. But the limiting condition is the applied force, external force, should be more than or equal to the inertial component. If it is equal to, you call it as impending force, where it will try to change its state from static to the dynamic state. So first law, Newton's first law, gives the concept of inertia. This is the first point that we should understand. And it's very important. Whereas when you come to the second law, second law defines the concept of force. It says that the rate of change of momentum is equal to force. So it defines force as a rating function d by dt of mass into velocity. So the concept of the force is different from Newton's second law of motion, which says that force is rate of change. My dear friends, if you try to observe it very meticulously, let us apply the concept of product rule from calculus to this particular thing. So if you try to write this particular force, if this is some x and if this is y, then what you do is in product rule, first you keep this as is, differentiate second, plus you keep the second function as is, differentiate the first one. So whenever you are writing it in terms of it, you will write it as, say suppose if you are writing it x into y dot. Y dot is differential plus x dot into y. Or in other words, what I am doing is this x is nothing but m into differential of the second du by dt plus differential of the first function dm by dt into u. No textbooks gives you this. In fact, you should always look force in this particular way. So whenever you are writing force, which is a vector, is equal to if the mass of a particle, if it is solid mechanics, or if you are looking at particle mechanics, where mass is not variable, then mass is constant m into du by dt rate of change of velocity is acceleration. Plus, when mass is constant, change in mass with respect to time is zero. This is for your particle mechanics. Particle mechanics. But there are situations wherein you come across mass is variable. So suppose there is a rocket fuel that is being fueled as a propellant, and then when you are firing it, when it is getting ignited, you observe clearly that the burnt gases will pass through a nozzle where there is a rate of flow of these particular gases through the nozzle, which will give you the thrust on it. In such situations, mass is there is no variation in velocity, there is no rate of change of velocity, but velocity remains constant, but mass flow rate varies. In such situations, you will take the second function wherein force is equal to mass flow rate into velocity. This is variable mass systems, mostly fluid mechanics. So, if I recap and look at it, Newton's first law of motion gives concept of inertia. Newton's second law of motion gives the concept of the force. It says that the rate of change of momentum is equal to force. And you should know that force is always a vector quantity. It has both magnitude as well as direction. If I change the direction of it, the force vector has a negative sign. So it is directional proportions. And this particular force vector is written in terms of calculus as two particular terms, mass into acceleration plus mass flow rate into velocity. Whenever mass is constant, you write it as force is equal to mass into acceleration. When the force and product of mass into acceleration were equated as vectors, it is in static condition, or you will write that force vector minus m into a vector is equal to 0. Or in other words, I'll keep this as plus, keep a minus sign. I'll write sum of force vector plus that inertial vector force. Always seems to be, it is in static. So, inertial force is always a pseudo force. It acts in the direction opposite to your force that is being applied, or it acts in the direction of decelerations. So, Newton's second law gives the concept of force, and in my next frame, I'll try to go with Newton's third law of motion, which talks about for every action, there is equal and opposite reaction. For every force and its effects, it has equal as well as opposite reaction. For every active force and its components, it has an equal reactive force and its components. So these three particular laws governs the major aspect of mechanics. Whether it is rectilinear motion forces that are causing rectilinear motion or curvilinear, you observe clearly that these active and reactive components exist. Thank you.